Hello, welcome to the Mark Janard Show, the cybersecurity show. In this video, I'm going to discuss why Linux is destroying Windows in regards to gaming. So, without further ado, let's get right into it. We're going dark. So Linux has made significant strides in gaming performance and user experience, challenging Windows' long-standing dominance. So here are key ways Linux is outpacing Windows in gaming as of this year. There is the superior gaming performance in many titles. So recent benchmarks show Linux not only matching but sometimes surpassing Windows in gaming performance even when running games through compatibility layers. For instance, games such as RoboCop, Rogue City, Banishers, Ghost of New Eden, and God of War Ragnarok have demonstrated higher average frame rates, at better 1% lows, which is the minimum frame rates on Linux compared to Windows, sometimes double-digit percentages at 1080p and 1440p resolution. So Unreal Engine 5 titles and CPU-bound games are particularly favorable for Linux, right? With some titles running up to 23% faster on Linux than Windows at 1080p. There's reduced system bloat and better resource management. So Windows has become increasingly bloated with background processes and telemetry consuming more system resources. So this bloat can negatively impact gaming performance, whereas Linux distributions, especially those tailored for gaming like Steam OS, are leaner and allow more system resources to be dedicated to games. There's smoother gameplay with fewer stutters. So Linux, especially when using Steam, preloads shaders more effectively, significantly reducing in-game stutters. So this leads to a more smoother gaming experience, particularly noticeable in demanding or newly released titles. There's enhanced privacy and freedom. So Linux offers a gaming environment free from pervasive telemetry and adware increasingly present in Windows. Gamers value the increased control over their system and the absence of forced updates or intrusive background services. There's cost savings and hardware longevity. So Linux is basically a free and open source, basically eliminating licensing costs associated with Windows. It also extends the usable life of older hardware, as Linux distributions tend to have lower system requirements and better support for legacy devices. There's rapid improvements and community support. So the Linux, gaming ecosystem is evolving rapidly with frequent updates to compatibility layers like Wine, graphic drivers, and gaming-focused distributions. There's community-driven projects that ensure that bugs are addressed quickly and new features are implemented efficiently. There's the near parity in game library and compatibility. So thanks to many compatibility tools, the vast majority of Windows games are now playable on Linux with minimal setup. Performance differences are shrinking, and in some cases, Linux outperforms Windows even when running games through a translation layer. However, there are limitations and remaining challenges. So some anti-cheat systems and specific multiplayer games still do not work reliably on Linux, which remains a barrier for certain competitive titles. In highly GPU-bound scenarios at 4K, Windows can still edge out Linux in raw performance for select games. So not all game launchers or DRM systems are fully compatible with Linux, though this gap continues to narrow each year. Now, one of the things that I didn't talk about much, but I will get into right now, is how Proton improves the gaming performance on Linux, right? It's kind of like Batman Robin kind of stuff, right? So Proton, basically is developed by Valve and is a compatibility layer that allows Windows games to run on Linux by translating Windows API calls like DirectX into native Linux equivalents, primarily Vulkan. So while one might expect this translation to always introduce performance penalties, real-world results in 2025 show that Proton can actually improve gaming performance on Linux in several scenarios, sometimes even outperforming Windows. So let's look at key ways. There's efficient resource management. So Linux generally has less system bloat and background processes than Windows, allowing more resources to be dedicated to games. This can offset or even overcome the overhead introduced by Proton's translation layer, especially on AMD hardware. There's better shader preloading. Proton, especially when used with Steam, preloads shaders ahead of time. This results in significantly fewer stutters and smoother gameplay compared to Windows, where shader compilation can cause in-game hitches. There's superior performance in CPU-bound titles, translation to more efficient graphic APIs. So Proton translates older Windows graphic APIs like Direct 3D 9, 10, 11 into Vulkan, a modern low overhead API. So Vulkan is significantly more efficient than older DirectX versions, allowing better CPU utilization and less bottlenecking, which is particularly beneficial in CPU-bound games. There's lower system overhead on Linux. So Linux distributions generally have less background bloat than Windows. Windows often runs numerous background services like antivirus, telemetry, updates, etc. that consume CPU resources. So Linux has become more streamlined, which basically leaves more CPU headroom for games, which can result in higher FPS in CPU limited scenarios. There's advanced synchronization features, so eSync and F-Sync, Proton elements eSync and F-Sync, which optimize how the operating system handles synchronization between game threads. This reduces the overhead from thread management and context switching, which is especially impactful for games that heavily tax the CPU. F-Sync in particular can yield substantial performance gains if supported by the Linux kernel. There's improved driver and kernel efficiency, so the open source Mesa drivers, especially for AMD GPUs, are highly optimized for Linux and Vulkan, often outperforming their Windows counterparts in CPU-bound games. Additionally, Linux kernel scheduling and memory management are generally more efficient, further reducing CPU overhead. There's reduced desktop environment impact, right? Like lightweight Linux desktop environments use less CPU and RAM than Windows graphical shell, further ensuring that more system resources are available for games. Game mode and performance tweaks is another factor. So tools like Feral Game Mode automatically optimize system settings like CPU governor, IO priorities, etc. When games launch, squeezing out extra performance for demanding CPU heavy titles. That's how Proton, does its thing. Now, there is driver integration and optimization, right? On AMD GPUs, Linux drivers are tightly integrated into the kernel. And again, they're better optimized for Vulkan, right? Which Proton uses on its backend. This can lead to performance parity or even gains over Windows, particularly in the Vulkan, or DirectX 1112 games translated to Proton. There's game compatibility and out-of-the-box performance. So for many games, users can simply install Proton, select it in Steam, and play the minimum setup. Basically, in most cases, the performance is on par with Windows, and in some cases, even better, especially for games that have not been heavily optimized for Windows 11 increasing system overhead. There's limitations and variability. So NVIDIA GPU performance on NVIDIA hardware, Proton's performance can lag behind Windows, especially in DirectX 12 games due to less optimal driver support and closed source limitations. Performance drops from 10 to 20% compared to Windows basically are still common in NVIDIA users, though improvements are ongoing. There's game/engine specific results. So some games, especially those are, basically with heavy anti-cheat or DRM, may not run as well or not at all under Proton. Additionally, certain games like Counter-Strike 2 at high settings still perform better natively on Windows. Now, here are games that are basically reported, they're basically better at running through Linux than Windows, reportedly. We have Factorio. The native Linux build on Factorio consistently runs significantly faster than its Windows counterpart, with users noting 25 to 30% better performance and faster saving, especially on large bases. There's Minecraft Java Edition. So Minecraft Java Edition often performs substantially better on Linux, likely due to its Java optimization on Unix-like systems and Linux superior OpenGL support. There's Apex Legends. Some users have reported a solid 10 to 15% FPS boost when running Apex Legends on Linux compared to Windows. That's what I have for you today. Please take a moment right now to hit that subscribe button and the like button. If you want more videos like this, hit that subscribe button, hit that like button. I appreciate your viewership. Stay safe. See you on the next video.